afternoon, everybody. We have been talking since morning about design, and planning. Let's come to discuss about execution. And something Dr. Desai spoke in the morning, that India is going to get 20 lakh number of beds in coming few years. What is more important? I mean, we can talk about design, but how to execute? How to execute in a limited time? And that is where today's topic of our discussion today is. And that is prefabricated buildings versus conventional buildings and the India's perspective. We have esteemed panelists with us, Mr. Kiran Teni, who is doing prefabricated buildings. He is constructing prefabricated buildings. We have Mr. Tushar, who is one of the major contractors in India, and executed a very premier hospital, that is Tata Cancer Hospital in Varanasi, which is into steel building, completely steel building. And we have Kushal Gupta from Max, who is also doing a great amount of prefab construction within Max. So with this, let us start today's discussion. Before we start, let me just give you some insights about what prefab buildings is about. So we are talking about speed. We are talking about modularity. We are talking about quality and hygiene. These are the some factors what we are talking about, and that is why one look after pre-engineered building. Because pre-engineered is about you are able to plan everything in a factory, construct everything in a factory, and then take those modules on the site and construct it. So it gives you that speed when you are actually constructing. However, we have very limited examples of pre-engineered building in India. I was just researching about it, and there were around about 8 to 10 buildings only, or hospital buildings in particular, what I will just take some names. JSW Sanjeevani Hospital, Acme Healthcare, Satyasai Sanjeevani Hospital, Apollo has done some good amount of work, Max has done, or Cancer Hospital, Tata Cancer Hospital, and some of the projects in Manipur and Imphal, which has been done in steel construction. So let me put the question to Tushar. Tushar, what do you think, what is the reason that we are not yet going for prefab buildings? I mean, that is the main thing what we would be discussing today. That what is the reason that while it is giving you the flexibility, you are able to do the things with utmost speed, but still it is not the thing in India that, and what we are mind-boggling numbers, what we are talking about, that 20 lakh beds is around about 1,000 bed hospital which we need to construct. Still, we are not doing it in steel. So over to you, Tushar.
Okay. Good afternoon, everyone. It's a very pertinent question, Manan. If I need to straightway, get to the point. Every project starts with an intent. Now, just to give you an example, as you said that, and we have executed this Tata Cancer Hospital project. From a barren ground to a completely running facility in 11 months, inaugurated by the Prime Minister way back in 2018. Yes, there are certain impediments. First is the intent, the budget. As we say that I have just to give you an example, the Tata Cancer Hospital roughly around works out to be around 5,000 rupees per square feet, which was done in 11 months' time. If I have to give you an example of a hospital that we have just completed in Borivali, which is for MCGM, That is done in 27 months with the same amount of square footage that we've incurred on that. So of course, one is the intent, second is the cost that you encounter, okay? And now if you see in the current ecosystem of the built environment, all the technologies are available which are available across the world. Now, how to assimilate those, where the architect's creativity comes into picture, what kind of selection, we just had a panel discussion about the selection of the right elements for doing it. And of course, as a contractor, we come at the fag end of the entire value chain where we get the drawings and we have to execute it, right? So ma'am is laughing at me. But yes, ma'am, that's one of the things that is there, that as contractors, unless and until we get involved in the design stage where we can bring in the constructability angle as to what could be the right way. I mean, when we talk about pre-engineered building, it's not only the pre-engineered building, because apart from the building, there are a lot of non-tower areas, the other ancillary units which can be done parallelly with a similar kind of technology. Why you want to incur a top-notch cost? Why can't we try and moderate the cost? So all these things can come into picture when a contractor can be involved in the design and build process. As you might be aware about the FIDIC tagline, the contractor-led design build process, wherein all the efficiencies on the construction point of view can come into picture. The Tata Varanasi Hospital was one of the projects that came up. And before that, we had never done. We only heard that the Chinese were doing faster construction. But we completed the project. It was a GC contract that we executed. So the most important thing for a GC contract for us was to get the right partners. So we got one of the top vendors on the structural steel side. We got the top vendor on the interior. We got the top agency on the MEP side. That's why it is not that Capacite did it. It was a collective effort. And there was a whole lot of help from the architectural side. If in case, from a constructability angle, if it was not being able to execute at site, we could immediately amend that and do that. So from a barren ground, as I said, 11 months we were able to hand over the entire hospital, which included the LINAC bunkers, the radiation therapy rooms, the basements and everything. So I was really fortunate to go and see the project after 6 years, and it is standing as it is. Yes, I was not very happy with the kind of cladding we did. We could have done better. But anyways, I mean, as I said, we have to just follow what has been given to us as a contractor.
That's fantastic. 11 months.
Yes, 11 months, wow. Yes.
So how LINAC was done in...
that was done in RCC. When we talk about a composite building, it's never a total steel. The core went in RCC. Right. The LINAC bunkers were executed with 2.5 meters thick walls with 8 meter high. That was done in RCC. And of course, the structural steel elements were then, the slabs. And then we had the IPD, OPD, and the radiation therapy room, which 2 blocks were again connected with an air bridge, which was connected with a truss. So we could do it. I mean, within 4 months, I have a time-lapse video, I can share that. Within 4 months, we were able to erect the structure.
And there was a basement?
Yes, a part basement, because the topography of the site was...
That's the reason that you were able to construct in 11.
I mean, see, basements in a particular building or a structure is one of the biggest things which sucks away the total timeline of the project, because a lot of waterproofing is involved, so many other things are involved, So it takes time. So if in case, as a part of the design and if the particular plot gives that flexibility and the client's intent to do faster, we can construct.
And what, according to you, Kiran, the major hassles or challenges that India is still not into prefabricated buildings?
Yeah.
I mean, you are executing, but I'm sure you are also facing that.
Yeah. And thanks, Manan, and very good afternoon to everyone. As Tushar was saying, the cost is the major impediment. Like right now, if you're looking at the structure cost alone, if you want to build a prefab structure or steel structure or precast concrete structure, it increases the cost by 40 to 50% on the structural point. So that's the major issue.
Is it 40% or 20-25%?
Of the structure cost.
Of the structure cost.
Of the structure cost alone. So, I mean, overall project cost, when you compare it, it may be 15-20%, but on the structure cost, it will be about 40 to 50%. So the moment that delta comes down, then you will see more adoption in the prefabricated structures in India.
But do you think that delta can come down? I mean, you are continuously. So what do you think that how that delta can?
Yeah. So if you look in my company, we do a lot of innovation in hybrid structures, combining steel and precast elements. and also cast in situ. That's one of the technology that we are developing, and then definitely a hybrid system. If you're looking at the cost factor, hybrid system will be in between a conventional system and a fully steel structure. So that delta we are able to bring down a bit, but still, because of the conventional construction cost in India right now is very, very, very low compared to the developed countries. That is why we see the less adoption in India.
How is quality getting impacted when we are talking of prefab structure? Tushar, you talked about you could have done the facade much better, but otherwise, in terms of overall structure.
Okay. So see, it depends upon agency to agency who execute the jobs. Specifically on the facade side, it was a wet cladding. Okay, it came in panels of 4 feet by 6 feet, and imagine that you have to align those panels till 8 floors. So when you see, there is always a joint in between. So I think we could have made a mix and match wherein the dead walls could have been done with ACPs and only the highlighted portions. From an architectural point of view, I think we could have done, but again there was no time. We had to, and of course since it was in Varanasi, it had to be given a kind of a temple look, so that it merges with the overall the facade of the city. So that's how it was done. But of course, see, just to give you an example, we have also done the tallest residential building in composite, which is 210 meters. It is in Pedder Road, which is called as Loda 1 Altamount. So if you travel on the coastal road, and if you see there is a pencil-looking building, which is black in color, with the developer's name on top of it. So it was a necessity rather than a kind of construction tech that we wanted to put, because we had to do a noiseless construction. We were in vicinity of the top corporates of India living in your neighborhood, so you could not work. There were time restrictions. We could not do any cast in situ. Yes, but of course the core was done in automatic climbing system, and then all the slabs were in structural steel. Now the biggest thing that, just to answer your question, Manan, that the quality parameters.
Yeah.
When you're doing it in steel, of course, the fireproofing plays a very major role. The method in which the fireproofing is done also matters a lot. There could be specifications of a vermiculite paint or intumescent paint, and how you try to camouflage it. For a layman, if he goes into a composite building, he will never understand what kind of structure it is, because again, the end columns are encased with concrete, and then there are false ceilings and everything. So in a way, how the workmanship has been done matters a lot. Okay. So again, as I said, it depends upon agencies to agency. A skilled contractor would be able to do it much better. Of course, the kind of partners that you choose for the delivery of the metals, the sections, the joineries, everything right from the metal decking, and of course, after that you do your, the concreting of the floors, how it is done, and then how you encase it. The one Altamount project that we did, and the entire building was encased with a curtain wall. So there was no need for you to do a kind of a block work, because with the aging of the building, the joints of the block work, or even the plaster, we have seen, the early settlement cracks coming in the building. So it again depends upon the specification, the kind of money that a particular client would want to go ahead and, invest in the project.
So let me put a question to Kushal. I think Max is doing a good amount of thought has gone into doing some expansion work in steel. So, but at the same time, we spoke about the cost, and there comes the ROI. Whether by putting the structure much faster, whether you are able to get the ROI or not. So, what is your experience, or when you are planning to do your projects in steel or expansion in steel?
So when we talk about the expansion of hospital,
can you just take the mic a bit? Yeah, thank you.
So when we talk about the expansion of existing hospital, so definitely no doubt the prefab structures are more suitable, because when you are expanding the existing hospital, you need to take care about the existing operations. So where we cannot more compromise in the existing operations while the construction is going on. So ROI is something which you need to find out how much amount of operations are compromised during the construction. So there is a loss of revenue there also. So you need to calculate properly where your construction cost is increasing 20–50%. Where if you are able to save in your operations, so ROI is better, the construction is faster, you can add the capacity quickly when you are going for prefab construction. So you're definitely for the expansion, the prefab construction is more suitable than the conventional RCC.
And I guess we are talking about noise factor as well when we're talking of...
When I say these operations are minimal disturbance, so all those factors are accounted.
So in existing building, it makes a lot of sense because
go
probably you have services on your terrace.
Yes.
So in a existing building, taking the services out, you probably might be having AHUs of the OTs on the top and removing them and doing the construction. All that is a big hassle. So probably in steel, it works out.
Right. So when I give the example of our Nagpur Max, so where we are adding 2 floors on an existing structure, so entire MEP services are placed at terrace level. So we strategize our constructions like we put a 2 floor. So first we put a top terrace, shift all existing services. Then we are going to construct the middle terrace, middle floor. So there is a minimal disturbance of operations. You need a such shutdown for the 2–3 days only to shift the services. And you can sequence your construction like everything is manufacturing off-site in a factory. You just need to bring those sections at site and bolt it, and you can do it quickly at site. So that is the biggest advantage for the...
Okay, great. So let me just get into what about safety? We talked about quality, but what about safety? Are we equipped within India to do prefab building and yet ensuring safety is in place?
Yeah, if you're looking at safety angle, any prefab structures, especially if you have more minimal works at site, the number of labors you require at site is much lesser. So in fact, one of the project recently we have completed, about 1 lakh square foot, it's hardly been done with 15 to 20 number of people. So wow. 10 people for erection and about 10–15 people for doing the finishing works. So with the number of people coming down itself, you have better control on the project and also on the safety side. And generally for prefab, you use advanced machineries or equipments for erections, which will also make the overall process much safer.
Also, I guess one very important thing is you need to plan everything beforehand. You cannot, when you are thinking of going with a prefab, you cannot be doing the changes on the go. Is it?
Yeah, it's better that you plan everything upfront so that you can have the efficiency while you construct. Otherwise, if you in between make changes, then again a lot of amount of time you will have to spend on the design correction and then again doing the fabrication. All these things will take extra time, which will again hamper the timeline of the prefab project.
Did you have any sort of experience like that you were doing any project?
Yeah, in fact, one of the project we completed a couple of years back, we had a tower line coming in between, and somehow the consultant didn't notice it, and it was supposed to be an 220 kilowatt or something. Now it is only 66 kilowatt, but then you have to keep an extra setback for the 220 kilowatt. So we have to, already erected structure, we have to dismantle it, redo it, and then again install it. And it took us about 3–4 months time for the whole design and construction process of that piece of it to happen. And it was possible, it was more easier since we were going for prefab, rather than if you have done it conventional way, we have to demolish it and then redo the whole thing. Here we could have, we can dismantle the stuff and then refabricate it and erect it.
And, if I may just add to what Kiran is saying, see, pre-engineered building is something that is engineered earlier. Okay, so in case of a composite, all the sections are designed earlier. They are given, they are sent for fabrication, and of course, you don't have for a large facility. I mean, just imagine that a project requires more than 3,000 metric tons of sections or the structural steel, and it comes from the factories. So factories are not always nearby. You have to be dependent on a suitable or a credible vendor to do that job. Just the Tata Varanasi project, we got our sections from Bellary in Karnataka, and the project was in Varanasi. Imagine the kind of logistical challenges, imagine the kind of supply chain elements that were brought into play in the design elements. So we could not go wrong anywhere because it was a very strategic, important project. And we had to plan all these things. So the design development stage, in a pre-engineered building plays a very crucial role. Once you get the section inside, then forget it. The tall Altamont project that we did, everything was, and the advantage of pre-engineered building is you get these sections at 12 meters. So you can erect one vertical, at least 2 floors you can cast, by putting in the decking and everything. So that's what is meant by the fast track construction. And then of course, all the other ancillary activities of, concreting and then column encasing, everything can go parallelly along with the MEP services. So that's the advantage. But yes, the initial capex on the material procurement, the design, finalizing it, and then of course integrating it with now the systems have come in, the BIM modeling and everything, which gives you a impeccable clash detection. It also helps you that in case the services need to pass, so can we do a castellation? All these things are decided on day one. You cannot go into the execution flow and then decide, okay, I forgot this, and now I need to take down my ducts or, pass on the lines and everything, because the false ceiling height, you have to maintain that.
So very interesting point. It is about integration of the services as well.
Yes, absolutely.
So it is not just the structure, but you have to plan everything before and think about services and how it integrates and dovetails into the structure. So Kushalji, putting this question to you is how difficult it is to integrate the MEP services into if we are going for a prefab sort of structure.
So when we talk about the MEP services in a hospital building, because the hospital buildings are more services intensive building, so there is a less flexibility in terms of steel structure while you are moving our MEP services, because everything you need to run below your ISMB beam. Whereas in RCC structure, conventional structure, we can give some sleeves to run at least fire services above the fall ceiling. So here we need to take a floor-to-floor height is more than the conventional structure. But also I want to highlight that while we are discussing about the conventional structure and the PEB structure, so we should not pose like they are competing with each other. So there should not be a choice. We should have a right balance of the both elements to be a successful building and achieving the target in all the terms, in terms of cost, effectiveness, and timeline optimization. So that is one of the most important thing, where we should not allow to compete these two methods with each other. We should give our market like they are complementing each other if we want to promote the PEB structure for the benefit of the industry.
So very pertinent point Kushalji has brought on table, that it is not both sort of way of engineering is not competing with each other. It has to complement, and we need to understand that what exactly we are wanting to do, and accordingly come up with a solution. And solution might not be just a conventional building sort of RCC, but it can be a hybrid solution as well. Or probably a hybrid solution is the way to go, and we identify that what are the things which can be modular, what are the things which is not modular. So anything which brings in the flexibility, one can plan beforehand and go for prefab sort of things. Yesterday we had a visit in Amrita Hospital, and we found the entire floor was having prefab panels, where the lab, entire lab was having prefab panels. So that was, I mean, you just do the floor and go ahead. Now we are having modular OTs, we are having cath labs, which are in modular way. So it is the way to go, at least when we are talking of speed. If we have to summarize this entire thought, do you think that we will be having more sort of, let me not put it that we are talking of prefab, more of these hybrid sort of structure in future?
So if you see, I was just going through some statistics that the healthcare sector contributes to close to 3.5 to 4% to the Indian GDP, which is expected to go 5% by 2030. And complementing to what you said, that the number of beds required, especially post-pandemic, everyone realized that there was a need. So if you see the kind of hospital projects that are coming up, it needs to be faster. Of course, it has to be a collage of different construction techniques which will help to make it faster. Of course, the integration of services also play a very important role. So the economics would definitely play a major role. Of course, the client, even the government organization needs to be prepared. As a contractor, we can suggest faster ways of construction so that any kind of impediment which impacts the overall, especially from the return of investment point of view, or getting the facility up and running, if in case it is in an area which really requires that. So all these things can be done. And I think the design element plays a very important role. The specs play a very important role. So we can go ahead and collectively make this happen.
Yeah, so design element play a big role.
Very crucial role. Very crucial.
And another very important thing is coordination of services beforehand. Because say if we are saving about a year, that is the maximum what you can save in a structure which is like a ground plus 10 stories. What was Varanasi hospital like?
See, Varanasi, we had to only concentrate on the facility, these 3 blocks. But apart from it, there were, see, as a client, they always have a flexibility to prioritize as to what is my important building. Any kind of ancillary structures, the nurses' hostel or any kind of admin block and everything can be a parallel activity which can start. So it need not necessarily be it can be in precast, it can be in steel. That can keep on happening. So again, as I said, the intent of the client, how faster he needs to come in. Of course, he also needs to have a space to do all these things, because precast elements getting at site, there requires a storage. There are special tower cranes to lift those heavy elements. So the entire engineering needs to be studied beforehand, before you hit the ground. Varanasi, we were, and that project was handled by us from Mumbai. We never had an office in Varanasi. The North Zone office also was busy. So we had to manage this entire project. So very effective project management, supply chain management, design management all led to this entire success of the project, and we were up and running. Of course, the MEP. See, one important fact here that we need to really understand is the maintenance of the building post you have given. I'm a contractor, I would construct a building, follow my DLP timeline, and I'll move out of the project. So the facility management plays a very important role. There's a lot of condensation which happens. The Tata Varanasi that I went, there is overwhelming, when you see the kind of patients standing in line to get in and out of the facility. So you have those air curtains, you have, the doors opening and coming. So there is a whole lot of condensation which you can see in the louvers, That is something that from an MEP point of view, there needs to be a designing, there needs to be a thought, okay? How can that you not increase the load of the building, get the services down if you have an area, so that the structure becomes light, it becomes much economical to construct, and the vibrations that you're talking about does not come in the future. So again, as I said, that the engineering needs to be proper. Of course, it translates into an effective execution.
Okay, thanks a lot. Kiran, you were wanting to add.
Just to add to what Tushar had said, we need to select the right materials. When you say prefabricated buildings, you generally think about steel structures. It's not just steel structures. There are a lot of other technologies are also available, like precast or hybrid. So you need, and also within precast itself, you have different type of technologies. We have shear wall systems, you have framed construction with infill walls. So you need to take the right system suitable for the right project. For example, I would say for a hospital project, shear wall systems won't work well because that don't give you the flexibility. Later, if you want to change the rooms, that don't give you the flexibility. So you need to choose the right system for the right project. That is key in the success of the project.
Okay, thanks. Any questions from the audience? Yeah, Dr. Desai.
Question to you, Kushalji. Generally, EPC has been, I mean, this pre-engineered part of it goes more in, sectors which are like he tried to do for public sector. Another one also in Gujarat was done for public sector. Why is the private sector not going for pre-engineered? Is that a cost element only, or?
Right, so the cost element is the major role which is going to stopping the private
So how much
sector.
is the cost, difference between
So when we compare both the quotations, when we get the PEB structures and conventional, there is a 25 or 30% is the cost difference.
That's quite substantial.
Right. So, but they rightly pointed out if your design is already done, so the supply chain is already in place, and you execute in a proper sequential manner, that difference of cost can be minimized.
And the difference of cost or the ability to earn early is more important.
Right. So when we talk about the hospital projects, where the early operations are having the impact on overall revenue generating capability, so where we can offset our construction cost to start the early operations. So, but somehow the industry is not reaching in that direction, because the adoption of technology like software like BIM is not implementing each and every level, like contractors are not adopting those software. So the construction is not exactly is like, manufacturing to construction kind of concept.
And the cost is because of what? Because high cost of steel, or because you need to fire protect the building or something like that?
So the fire protect the building is playing the 5 to 10% more, and the steel cost is also is there, because there is a 20% additional steel you have to put when you are going for the prefab construction versus.
Sir, I just want to ask about the sustainability aspect of prefab.
Can you introduce yourself?
My name is Ankit. The sustainability aspect, is the embodied carbon level higher when it comes to prefab, precast structures, and from a decarbonization perspective, there is a lot of talk about that. Could you just compare that, the conventional versus prefab?
So to be very frank, I am not very deep into it, but just as an art designer, I can say the decarbonization component is higher in a steel structure, because you are using steel in at least 20-25% higher than the conventional construction. So you are using more natural resources to build the building. So therefore, I think there should be a more carbonization.
And just to add to what Kushal said, there is less wastage when it comes to steel construction. In concrete, there's a whole lot of wastage. Concrete production requires a whole lot of carbon emissions. And our industry, as you're aware, that we contribute to almost 30-35% of the green gases. The faster you construct, the faster you move out, the reuse, the wastages are less. So yes, in some way, it goes ahead and contributes to towards the sustainable development. Of course, the sustainable development should not be looked into isolation of only the structure part. It also plays a very important role when it comes to the overall HVAC or the entire MEP. Anything consuming energy would emit carbon, you're aware. 1 cubic meter concrete production emits 4 kg of carbon dioxide into the atmosphere. These are the stats that I've read as a part of the sustainability report. But we can try to minimize that. How we can be effective? I've just been at JUD L1 in one of the very important strategic projects for IIT Mumbai. There, outside the curtain wall, they're putting terracotta slats. Why they're doing it? in order to lower down the load onto the chillers, so that the natural ventilation takes care of, the load on the chiller. So again, as I said, it's all a part of the design element. You design it proper, you be sure what you want to do, the execution is the easiest part to do.
Fantastic. So, very interesting discussion today. And thanks to all the panelists.
Thank you.
With this, we'll close.